Light and reflection. What is light? Visible light is electromagnetic radiation that is viewable by the human eye. Some common sources of light include the sun, light bulbs, and candles. Light travels in wave fronts. We represent the direction of motion of light by constructing perpendicular lines to the wave fronts and calling them light rays. Geometric optics studies the behavior of light rays as they reflect off mirrors and refract through lenses. So if here's our source of light, let's say it's a light bulb, we can imagine the waves kind of going like this, like wee, like this, where these lines here, these wave fronts, represent the crests, the tops of the waves. And then what we do is we just draw these perpendicular lines to the wave fronts that show the real direction that the wave is traveling. And those are perpendicular to the wave fronts at all points. Here, let's say we're really far away from our light source. The wave fronts basically become parallel to each other, and that's called a plane wave, when we just assume that the wave fronts are all parallel, and then the light rays are also perpendicular to the wave fronts and they're parallel to each other. You can see a pencil on a desk from any angle, as long as there's light in the room and nothing in your way. There's not like a giant boulder between you and the pencil. Light rays from the overhead light here reflect off of the pencil in all directions, but as long as some of those light rays make it directly to your eye, you can see the pencil. If you are in a pitch black room, you can't see anything because no light rays are bouncing off of objects and then ending up at your eyeball. The law of reflection states that the angle of incidence is equal to the angle of reflection. All angles in geometric optics are measured from the line normal or perpendicular to the surface. So let's say this is a mirror here, this green line here. The normal line is a perpendicular line to that surface. See how that's a 90-degree angle between the surface and the normal line. Here is the light ray coming in this way. That means that this angle here between the normal line and the incoming ray, that is the angle of incidence. And this is the reflected ray. So the light's going to go that way. Therefore, this is the angle of reflection. When you look into a mirror, so this is like a regular mirror, we call it a plane mirror, also called a flat mirror. You see an image of an object that appears to be inside of the mirror. This is called a virtual image, since the light rays that meet your eyeball are not actually coming from the object. The light rays just look like they are coming from inside the mirror. Human eyes did not evolve to understand mirrors. When you see an image in a mirror, your brain thinks that that's where the object really is. Your brain assumes that the light rays reaching your eyeballs must have come from inside the mirror. The human brain assumes all light travels in straight, uninterrupted paths. So even though the actual light rays are going from, let's say, the sun, bouncing off of this object into this mirror, the angle of reflection, we have our reflected ray that ends up in your eyeball, right there. Your brain's going to think that it came from an object over here. So that's why it's called a virtual image. These are not real light rays. These are virtual light rays from inside the mirror. When you look in a mirror, you see an image which appears to be behind the mirror, also called the dark side of the mirror. The distance from the object located on the light side to the mirror, so this distance here, we'll call that S sub O for object, the distance to the object, is the same as the distance from the mirror to the image. We'll call that S sub I, the distance to the image. A virtual image is formed by extending the light rays to a place where they converge on the dark side, over here. This image cannot be projected or focused onto a screen. An observer can only see the image of an object in the mirror if the light ray from the object strikes the mirror at an angle theta I, angle of incidence, that will reflect it at an angle theta r, the reflected angle. And that ray there has to reflect and be able to reach the person's eye. A line connecting the image to the observer passes through the mirror. So this line here and that line there. And then obviously an infinite number of lines in between those 2 points. All right, here's a plane mirror. These little lines represent the back of the mirror or the dark side of the mirror. An observer at point A can see the reflection of this jug. So this is a real jug. This is our object. They can see the reflection here because there is a line that can go from the object. It can follow the law of reflection and bounce and then reach this person's eye. However, there's no image that can be connected to observer B that passes through the mirror. See, the mirror would have to extend down this way in order for this person to see this object in this mirror. There's no possible reflected light that can reach observer B's eyes. In your classroom, you can place an object in front of a plane mirror, like as shown here. Then students can go to places in the room where they can see the reflection of the object and other places where they cannot see the reflection of the object. Mark out these locations, measure the angles, and confirm whether the law of reflection holds true. You can use materials like string, masking tape, and protractors in the experiment. The other type of image, other than a virtual image, is a real image. A real image is formed at the point of converging light rays on the light side of the mirror. The light rays actually pass through that point, and therefore they can be projected and focused onto a screen. A real image is not formed by a plane mirror, a flat mirror, but it is formed by spherical mirrors and lenses in certain situations, as we will find out shortly.